So, DMI. Not sure that everybody knows who Daishowa-Murabeni is. We're up in Peace River country. I don't know if anybody's even gone up there. The presentation today, we're going to go over Daishowa's experience, I guess, with wet areas mapping, and give you some background on what we've been up against, and look at the benefits as well as where we see this continuing to move. So DMI is a fairly large player on the land base up in the northwest. We have a hardwood softwood pulp mill. We call it a swing mill. It can go either way. But we also produce a lot of power lately. 146 megawatt hours per year. 146,000 megawatt hours per year. This is after a fairly large green plan retrofit and enhancement of the mill. And we use, as you can see, a significant amount of volume. This is the lay of the land, and I was telling some folks at lunch, it's about 9 million hectares grand total. The 7.5 million hectares is once we take off some of the areas in the white zone, but either way you look at it, this is a larger area than the province of New Brunswick. And for those of you in the old system, that's 18 million acres. That's a large tract of land that we manage. We also manage in accordance with our guiding principles for stewardship. We want to maintain our social license, and in doing so, we're following the criteria of Canadian ministers with the maintenance of biological diversity, ecosystem productivity, etc., the society's responsibility for sustainable development, all that good stuff. And we use ecological-based management as our primary tool. As you probably know from last year, fires are on the land base in a big way. They don't necessarily come every year, but that's how the forest renews itself. So what we try and do is emulate that in what we do on the land base. One of the things that we use to evaluate whether we're doing it the way nature does it, or if we get the same kind of values out the other end, is EMEND. And this is the research that Barry was mentioning earlier on. And it was initiated in 1997. At its peak, we had 17 different partners in the program. And to date, we've put in over $14 million into the research. And ultimately, we want to see whether our harvesting techniques are coming close to what nature does with fires and that sort of thing. And what we found is that we can potentially come close to preserving biodiversity, ecological integrity, and ecosystem productivity, and still maintain some level of economic performance. And it's, I think it's actually the largest research anywhere in the Boreal, at 1,000 hectares of treatment areas. And what we've done, see if this works, what we've done is we're in the process of putting a protective notation of 7,500 hectares around that 1,000 hectares of treatment area to ensure that the experiment doesn't get destroyed by accident through other development. The intent is that this research is there for 70 to 80 years. And this just gives you an indication of the number of partners that have been at any one time involved in not only EMEND, but in a lot of the other research that DMI is working on. So some of the challenges. DMI is one of the few companies that we operate all year long. So we need to know where things are wet and where things are dry, because we're going to start up in mid-July to go and start harvesting our trees. And we essentially need to know where non-frozen operations can occur and where we can get our trucks and equipment into the forest. So this is one of the biggest issues, planning it out. How can we effectively plan out where to go and sustain these operations over the long haul? And as well, at the tail end, how can we ensure we plan operations so that we can minimize our overall liabilities once we're done? So the challenges continue, and that we have to integrate with all of the other forest companies. This is part of the process that we go through in our planning on both on a strategic level and an annual level. We also are getting better at integrating with the energy sector. That we find a lot of promise in working together with the energy sector to try and either work at the tail end in reclamation or in the front end at planning their plans together with our plans. Ultimately, that planning can help us to minimize both environmental and social impacts. Then some of the fun words, cumulative effects, we hear that a lot. That's what this is all working towards. It's trying to figure out a way to minimize the impacts on the environment, which can have all sorts of different avenues. You can impact your larger carnivores, your predators, your caribou, your different animals, but you can also impact frogs. You can impact insects. What we've put together in our method of management, we think tries to work together with the environmental, but also taking into account that we need to stay in business at the same time, and then working out ways to figure out what everybody's values are, so that we're not just keeping what we think is important, but keeping what everyone actually wants on the land base, such as First Nation values and treaty rights and trappers and even the general public. Now, this just gives you an example of what we're actually doing out there. We use a portable chipping system. So we have 10 portable chippers, and we'll actually take the chippers out into the woods and set them up and bring bee trains out into the woods, and in real time bring the trees from the forest, chip them, put them in the bee train, and take them to the mill. So in order for us to do this, we really got to know our access, we got to know our timing, and where it's frozen, where it's non-frozen, or we're never going to get the wood in. And one of the things that can happen if we don't plan this correctly, we start getting into these issues around water. And rutting is one of the big ones. And as soon as you get this kind of impact on the different forest areas that we're operating in, you're talking about a lot of money to bring that back. You're talking about reclamation of disturbed soils. Overall, we also find that if there's wet areas out in the stand and we take the trees off, the thing that's going to come back is grass. I don't know if you guys have been out in the woods in any of your sites out in the forest there, but it's called Calamagrastis, and it comes back very, very thick, and absolutely nothing grows but the grass. In our case, we need these trees coming up. If the grass comes back, we're basically, again, in a situation where we're going to have to spend a lot of money to bring trees back onto the site. So ultimately, we want to focus on minimizing our impacts prior to and during the harvest. And the long-term impact and the short-term impact is we're going to save money and we're going to reduce the impact on the environment so that we don't get things like this happening. And we will maximize the LFN chance, that's the leave for natural. We'd rather not plant if we don't have to. If we can get nature to bring it back, that's the better way to go. And we can do this by protecting what's there. This doesn't always work for oil and gas when you're putting in a site, but in some cases you can leave adjacent forest and it can seed itself back in. This is just showing you the various companies that we're working together with on the land base, and some of the multiple uses that we have to take into account. So there's one of our cuts. We have to consider the wildlife out there. We have to look at the various critters. We have to look at access. We even have to look at the people wanting to have fun in the forest. And believe it or not, the cows. Grazing permits are out there. And of course yourselves in oil and gas. Everybody's overlapping. Everybody's using the same piece of ground for something else. That's what we're trying to work within right now. And this is some of the oil and gas activities in our neck of the woods. This is a few years old. It's actually quite a bit more since then. But 67,000 kilometers of seismic, 5,000 well sites, 1,000 plus kilometers of roads, and over 1,400 kilometers of pipelines. That's just in our FMAs. So what we want to do is take integrated land management to the next level. We want to operationalize it. And we think that wet areas mapping is really going to provide the baseline for allowing us to do a lot of the things that we want to do. This is an example of where you see some of the activities that are on the land base, and it's mixed in with all of our forests. And we think there's an opportunity for us to work together with the oil and gas using some of the tools like wet areas mapping to bring things together. So here's a shot. Can everybody see the streams there? This is what's on the system. This is what Barry was talking about. This is what somebody was able to pick out on the photography. So the streams there in blue, these green ones, this is the channels that have come out of the wet areas mapping process. Just a tad different, I would think you would agree. And then this is the wet areas mapping. This is the depth to water associated with those channels throughout. And this isn't the exact same, but in the green, what we have here is our spatial harvest sequence. This is 70 years worth of sequence. And you can see how it's all interspersed within that, but you can also see the well sites interspersed within. So this is a great example of where if these, let's say these were to be reclaimed, DMI could actually work with oil and gas to come in, working around the wet areas mapping, but also integrating our spatial harvest sequence with the plans for reclamation to basically provide a win-win solution to reclaiming the area while minimizing the impact on the land base. And by us operating here, we would be minimizing our impact somewhere else. So that's an example of coordinated planning of forest projects and some of the operational considerations: utilization of WAM for road placement, camp placement, production pads, optimized corridors. This is where all the companies are using the same access into an area. And this is all something that can be worked together with the wet areas mapping leading the way. This is an example of an area that we just recently went into. This is what we had to work with, which actually wasn't that bad. This is from the vegetation inventory. But as soon as we put the wet areas mapping in there, it really did bolster where the ephemerals and the smaller draws out on the land base actually were. This is an example of what I'm talking about when I'm saying the ephemerals. It's those little draws. You can see the grass. You're walking in the woods, and you can actually see the grass and the willows, but you can't see a stream per se. There's no channel. And then you start going into you can see the channel, but there's no water in the channel. That's a good example of an intermittent. And those kind of situations, well, it's not a problem at any one moment in time. If you go and do activities in there, those will cause a problem when you get a heavy rain event. So we did a study just to test the situation. So single fall winter operating season, 2 forest industry contractors, just 4 operating areas. We typically have 10, and 143 water crossing points in that little area. 121 of those were ephemerals. This is things that are not picked up anywhere else. And this is stuff that is being picked up right now in the wet areas mapping. So here's one of our harvest blocks. This is a block that was actually harvested before we had the wet areas mapping. And a huge amount of effort went into finding these particular areas. These red areas are our retention areas that we set aside as stepping stones for wildlife to go across the land base and for providing islands of the kind of forest that was there before. And after we got, this is our wet areas mapping, you can see that the retention areas corresponded very closely to where those wet areas were. And this is kind of on purpose. This is doubling up on value. So if we harvest where it's wet, that's going to cause a silviculture problem. So if we can put the retention on top of that, we're going to maintain our retention at the same time as minimizing our silviculture problems down the road. You can also see in most cases the roads went in appropriate places, but this is a good example, whereas if we had better information before we put the block in, we probably would have gone through here, right in between. So that's what this is our poster child. This is a fairly significant block, but this is a good example of our retention that is left in the block. And these are the little single tree and clumps that are left within the block as well. Not your typical clear cut that people think of. Now this is a good example of harvest areas with the wet areas mapping turned on. And I think Barry actually showed you the example, so I went and changed my slide. This is another example showing a similar thing, where this is a area that was harvested almost 20 years ago, and the buffers that were left by the person on the ground correspond exactly with where the wet areas mapping has picked it up. Same in along here, same in along here. This is what we do now. We have totally integrated wet areas mapping into everything we do at this point. We don't do any planning without first having wet areas mapping integrated into the plan. So the wet areas mapping and the block is provided to the person that's going to go do the layout, and they are actually going out there and verifying exactly the way that Barry's talking about. And very seldom is there any changes made to channels but every once in a while there is modifications made to the ephemerals, because they don't always go where you think they're going to go. And wherever possible, the wet areas mapping, the wet areas are lined up with the retention areas. Here you see an example of a bear baiting station and a bear den actually falling in line with the wet areas. This is the kind of thing, once we get more information, we'll be able to get our GIS experts to hunker down and do all those calculations and figure out whether bear dens are typically in 0 to 0.5 wet areas depth in black spruce. That kind of analysis could end up providing us the information that we could then share with First Nations and basically tell them a little more information about the things that they value. This is another example just highlighting the same area but with the lighter on. Here's another example, and you see here this blue dot here is highlighting where a water crossing was actually put in, and it lines up perfectly where the ephemeral is. But you can also see where the road was planned to go right between the two ephemeral draws rather than right on top of the ephemeral. These would never have been even seen out in the woods. What we started finding is we just went through a 4-year drought, and we weren't seeing any of this on the ground for the first couple of years. So the operations were saying the planners were all wrong, and they did it the way that it should be done on the ground. And then we got audited because we're certified at the time to CSA, now to SFI. And in the audits, they said, well, your operations, they put their road right through that ephemeral draw. But the plan said they weren't supposed to. So what it came down to is we ended up trusting the wet areas mapping, because whether or not you have a drought, in this case an extended drought where there is no water, when the water does come back, it's gonna hit you pretty hard, because you're gonna start getting problems with the regulators, and you're really gonna have an issue with your social license if you're putting roads right through streams. In this case, just an ephemeral draw, but it's still a water body. That's just another example with the lighter on. So ultimately, and this has been repeated from a lot of the other speakers, wet areas mapping has actually transformed how we do things. It's turned everything around. We used to send people out in the woods to figure out what was there. Now we got our planners in the office, and they've got all their high-tech tools there, and they're figuring out where things should go, and we're sending the layout crews. They're going to lay it out, but they're just going to be verifying where the planners have said it should go, and to make sure that the streams are exactly where they are on the maps. And it's created a very efficient system. A good example is helicopter time. At $1,700 per hour, or maybe a little less, depending on the kind of helicopter you're using, you can save that money really, really fast if you don't have to be flying crews in to drop down and check out on winter operations during the summer. And that's exactly what we did. Within a few months, we paid for everything that we spent on wet areas mapping. Our present system is very efficient and in a lot of cases more accurate than we ever had with people on the ground. Because it's showing you things, like I was saying, it's showing you things that you can't always see. in a case of a drought and that sort of thing. Ultimately, it's minimizing risks, and that's minimizing our costs, and it's providing a system that minimizes those surprises. So you send your operation out there, they're not going to be shut down or moved to another site because of some surprise that they find out on the site. The advantages of using WAM, like I've been mentioning, planning layout, operations, reforestation, but we've also got the dialogue with First Nations, strategic evaluations, and it really is a platform for integrated land management. The cost avoidance, reduced helicopter time, enhanced layout planning. It's enhanced because, like I say, you're seeing things that you never used to see. When you walk a site, you don't walk every square inch or every square meter. Now you've got information on every square meter. And yeah, you've got a desk-based system. And it's not to say that you're doing everything at the desk. You still have to send people out or go out yourself. But now you're going out to verify what you think is there and reducing those very costly surprises. The cost avoidance, because you're now knowing where to put your roads, you're going to have fewer crossings. At $1,000 to $2,000 per crossing for just a log fill. But if you put in a high-priced crossing, you could be talking upwards of $5,000 and $10,000 for a crossing. Well, if you use wet areas mapping, you can find the best route to go in to minimize those crossings. Those crossings are also the points that you get most sedimentation going on in the water. You also have your reforestation. Now you can move your I guess for you guys it's moving your pad to the most appropriate place so that you don't get flooding of your production pads. You've also got the compaction and decompaction. Whoa. And for us, reduce moves. Because you're not hitting those surprises, that's what used to happen. We'd send a full crew out to go and harvest the site. They'd get 10% into the block, and lo and behold, there was a large wet area right square in the middle of the area that essentially made the area untreatable in the summertime. And they'd have to move. At $10,000 a move, it adds up. And then the paperwork. The paperwork, it's the worst, the paperwork. And not that dealing with the government is a bad thing, but they don't like the paperwork either. And the TFAs, constantly going back for TFAs. So any time you can reduce the paperwork and streamline the operation, government loves it too. Then reforestation. Now we've managed to work out for ourselves anyway opportunities so that we've minimized reforestation on the land base. We've gone from a case, and Aaron knows this all too well, we've gone from a case where we were planting probably 500,000–600,000 trees per year. This is a deciduous company. We were planting white spruce because we had these areas that they were all grass, and we had to bring them back to trees. Well, now we've managed to swing our attention into those areas and almost completely eliminate that reforestation cost at probably 50 to 60% reduction. So that's an annual reduction, but we love that one. Reduced impacts on the site and maintenance of productivity. It just goes hand in hand. It's all part of the same benefit. Now, some of the more interesting things coming down the road is dialogue with First Nations. The values that First Nations place on the environment, a lot of them have to do with wet areas. Majority of the medicinal plants are occurring in these zones along streams in these zones where it is wet. Some examples are rat tail, diamond willow, just to name a few that they occur in those wet zones. Now, if we can take those kind of associations with the wet areas and analyze that together with the forest types, we could actually develop a map to indicate to the First Nations this is where you're most likely to find the species of plant that you're interested in. Examples that we've been doing this with Duncan's First Nation, Lubicon Lake. We've also been doing it with Tall Cree, Woodland Cree. It's the way to go, I think. And then strategic benefits. We're going into that integrated land management process, and all of these different evaluations that we're looking at here, fire patterns, biodiversity, ecosystem aspects, silviculture, regen response, all of these, because the wet areas mapping and the forest inventories are on a landscape scale, when we do some of these analyses, they can be applied across the land base, across the landscape, and even across the province. That's how, I think, Barry, you were saying 15 million hectares. So that's, we can do those kind of things right now. So we'd like to see continued integration of WAM into strategic analysis, and the correlation with research, obviously. That's for correlating a lot of the research that's already occurred and just do some additional analysis with the wet areas mapping. Do an environmental risk classification. Should be fairly straightforward to do that one. And integrated land management and ecosite classification. Barry's already discussed that. And correlation of First Nations values. And where we're going with improvements, it's pretty hard to go much farther than they were showing before lunch. But we're going for kind of the simple approach, so that everybody can have a GPS in their hand for a few bucks. And where we're going at this point, almost everybody has an iPhone, as it turns out. And we gave the tool to our ops supervisors. We gave them the iPhone, and they had the WAM, and said, figure something out. Well, they figured something out. You can make a PDF, and you can put it on your iPhone, and you can turn it into a routing tool. So you can have all of the flexibility of a PDF file right on your iPhone. Just turn it on to track, and it'll track where you are in the block with all of the information on the block map. Nickels and dimes, but it works. And ground truth stream coverage. After seeing today's presentation on crossings and things like that, I think that is our ground truthing right there in the works. And a culvert database, maybe we can get our hands on the government's database and we'll all have a culvert database. And this is just a saying that I picked up. Continued innovation, educated risks are the key to success. This is a guy, William Olson. I don't think he's wrong there. Just keep innovating. That's how you're going to be successful at anything that you're doing. And that's where we're moving. In the old way of thinking, we were pulp and paper and solid wood products. Now we're green energy, carbon, and we're looking at ecosystem services. And basically looking at anything that we do out there that gives benefit. Just gives you some examples. And once you start looking through here, you'll see how water trickles through just about everything in here. It's that platform for doing all of these ecosystem services. Water is a key component of it. And you'll see that again in here. And this is just for you to look at if you get this presentation.